Hello everyone, good to be here. I'm just going to run through a bit more of a detailed demo of the entire system, but I think it's really good to see the context of it from Juice's point of view, from an actual user's point of view as well. So thanks for that, Juice. It was really good. So this is the main login screen to DAFNI. You'll notice there's no register button or anything at the minute. And I think Marion and Mauricio have put the links in the chat to our separate registration form that we've got at the minute, but we are actively working on pulling that system into this system. So hopefully there'll just be one link for you to be able to go to and to register for a user account. But if you are interested in the meantime, please do use the link that Marion and Mauricio have put into the chat. So I'll log into the system and I'm immediately greeted by this front page, which shows me all the different things that I can do on DAFNI. So if we go left to right, we'll go to data first and have a look at the data catalog. So I can see some 2,138 data sets in this catalog. But if you were to log in as a new user, you would see a lot fewer than this. So I'm logged in as an admin user, so it happens that I can see everything that everyone's uploaded. But as a new user, you can only see stuff that people have made public. And that is a really important part of DAFNI. Everything that you upload as a user is private to you by default. And then you have to choose to share it with other people specifically. And you can do that by making it public, so everyone on the platform can access it. You can share it with individual people, or you can share it with a group of people, which is probably the most popular thing that our users tend to do. So if I just click into one of these data sets as an example, you can kind of see some of the metadata that we have available. So we've got some geolocation data. This is supposed to be the United Kingdom, but the bounding box service that we use is a bit weird, and it includes some small part of Africa as the UK as well for some reason. So that's not necessarily a DAFNI problem. It just looks a bit weird. And then you've got the files that make up this data set, and I can individually download each of these files and explore them. So if I had access to this data set, I could come in and start exploring it straight away. But I can also explore all the metadata associated with it as well. And as you said, these IDs are important for when you want to actually make use of this data set in a workflow, which I'll come back to in a second. So if I show you the way that you actually add a data set, and I won't bore you with filling this form in now, but I can essentially drag and drop my files into here and fill out all of the metadata information. We actually use a DCAT metadata standard, which we find is pretty good. It covers a lot of bases and also provides us with quite a rich level of metadata as well. So you've got things like the language the data set's in, you can provide keywords for people to search over, you can then provide the spatial extent. We currently can't allow searching over spatial area, but it's something that we're looking to add in the future with some kind of more advanced search. But at the minute, our search is kind of limited to a full text search over the description and title fields. So if I just type in OS green space, for example, and search, then it will come up with the green space data sets. And that's just a full text search, like I say, over the description and the title. But we also have additional filters down the side for the source of the data sets. You can see we've got quite a few data sets from the ONS. You can filter by subject and also file format as well. So that's kind of it for the data section. And the data section tends to just be used by people that want to use these data sets in their workflows. So they tend to be stuff that provides an input to a model, for example. And I'll show you an example of that now. So this is the model catalog, which again, will have a lot fewer models available for just an average user, but I can see everything that everyone's uploading and playing around with. And this is the model that I've just uploaded, and I can show you what that process involves. So when we upload a model to DAFNI, there are kind of two things that we need. We need a Docker image of the model. So that's like containerizing your model in a kind of package such that you can ship it off to us and we can unpack it on our side and we can run it in the exact same way that you do on your local machine. And so this is an example of a Docker file, which I'll just talk a little bit about. And if you're an experienced modeler, putting together something like a Docker file shouldn't be that complicated. And there's loads of tutorials out there. We're planning on doing a series of training videos about this as well. And we're actually already running a series of training events. So if you are more interested in this sort of technical detail, then feel free to book onto one of those. But Docker files always start with a from statement. So that's usually the base Docker image that you want to pull from. And in this case, I'm using a Python model. So I'm pulling from a Python base image. I then go ahead and install some packages that I need to be able to run my model, do a bit of sort of creation of file directories and stuff like that, but also add all my code into the image as well. So all my local code goes straight into the image, and then I install some Python packages, and the final line is always the thing that actually gets run when you run the image. So this is my script that starts off the model run. So this is one thing that you need, and I could go into a lot more detail about that, but I won't bother for the sake of this this meeting. But the other thing that we need is a metadata file, which explains all of the things about your model and all of the inputs and outputs of your model. So this model that we're looking at the minute is a UK climate analysis model that was developed by a guy called Amir Patel, I think, at the University of Liverpool. I can't speak to the sort of accuracy of the model, but what it seeks to do is to predict the future weather in the United Kingdom. So it predicts things like snowfall and rainfall, temperature, and the amount of sunshine as well. And so this file basically comprises a set of metadata about this model that I've written up. So you've got a short summary, a bit of a longer description. I've got a pointer towards the place where it exists on GitHub, so the source code. And then kind of the interesting bit is this spec section down here, which is where I can provide inputs to the model. So all of these inputs will be exposed to the user that runs the model, and I can show you how that works in a second. But all of these parameters here are exposed as environment variables to the model. So we kind of, on DAFNI, we try and abstract all of the kind of code away so that the person that comes and runs the model doesn't need to know about how it runs or the code behind it, but they can kind of just take all the metadata that the model owner has written and use that to kind of find out about how the model works and what they want to input into it. And so we take input parameters in the form of booleans or integers or strings, and these all get exposed in different ways through the front end, which I'll show you in a second. The second kind of input that we have is this data slots input, and this allows us to use data sets from the data catalog that I just showed you in the model itself. So here we take a load of UK CP9 data sets. So all the defaults point to files that already exist in the data catalog, so that we can just use those directly in our model. But what we could do is, as the user running the model, we could change these data sets out at runtime. So say UK CP18 comes out, we can change the UK CP9 data sets for the more recent UK CP18 data sets at runtime without having to change the metadata of the model or re-upload it or anything like that. We can kind of just swap those out at runtime. And again, I'll show you that when it comes to the workflows. And finally, you've got an output section, which just gives the user an indication of the stuff that is going to come out of your model ultimately. So what this actually looks like on the front end is something like this, where we kind of display it in a bit of a nicer way. You can kind of explore this much more easily as a user than exploring that kind of YAML configuration file. But actually, to upload the model, I would just go here and press add model, confirm that I've done all this stuff. And it's worth pointing out that we've got extensive documentation about how to write all of this stuff and how to actually Dockerize your model, and some tips and tricks that we've kind of come up with over the years. And then all I have to do is browse to the files on my computer, open those and upload. And that takes a little while because I think the image itself is some 800 meg, so we won't bother waiting for that. But I did do this earlier, Blue Peter style, and so this is the one that I did earlier. So now that we've got our model uploaded, we obviously need to do something with it, and to do something with it, we have to create a workflow. So Just demonstrated this really well, I think, and his workflows were a lot more complicated than the one I'm going to show you. So all you have to do is go into create a workflow. We enter some metadata, so I'll just call this UK climate. and I'll just copy and paste this for the sake of time, but you can obviously enter some better metadata here than what I've entered. Press continue. And now we can add our workflow steps, and there's kind of 3 steps that we can choose from here. Usually your workflow would begin with a model step. So that's a step where we actually take a model from our model catalog, run it on the back end, and then do something with the results. So we'll just call this UK climate. We'll select our model that we've just uploaded, which is this one. And we can create a step. But what we could also do is, in the case of like use workflow, obviously he had multiple steps and each step impacts on the next step. So we could also include data from a previous step. So that's how you build up these system of systems workflows, is by including previous steps data in your newest step. But since this is our initial step, we're not going to do that, because I'm trying to keep this as simple as possible. We're not going to create a system of systems workflow. So then we've got kind of 2 other steps, and these steps are to get data out of your workflow and to do something with it. So the publisher step type will simply take data out of your model once it's completed, and it'll upload that data into the catalog, so that you can then, you know, make it public or do whatever you want with it. We also have a visualization step, and as you showed, we can create Jupyter notebooks where we just upload your data into the notebook, and then you can write code in order to do stuff with it. We also have a drag and drop kind of visualization, which is kind of for users that aren't as technical, I suppose, and don't know how to write the code. And we hope that that will provide an easier mechanism for them to do the visualization. And so I'll show you that in a second. So if we add a publisher or a visualization step, we have to enter some metadata about the visualization, but we also have to enter the metadata for the data itself. It's actually coming out of the model, and that is the exact same metadata form that you fill in for the data catalog as well. So I won't go into that in detail again. And so once I'm finished with my workflow, it would look something like this one, where I filled in all of the metadata form and it's basically ready to go. And then what we need to do is create a parameter set. So this essentially allows us, I'll just edit this one for the sake of time. This allows us to configure the stuff that goes into our workflow, so the kind of config options and stuff. And you'll see the visualization option is grayed out here, because the only thing that's configurable about our workflow is the model itself. So you can see our input parameters from earlier have all appeared here in a much easier way. I can see the tooltips about them, and I can kind of configure those however I like. In this model, the only things that you can kind of configure is whether it processes rainfall, sunshine, snowfall. So I can kind of make it run a bit quicker if I turn those options off and only process the temperature data. But I'll turn them all on because it makes for a better output. I can also choose which season I want to base my data on. I'm not quite sure how this config option works in the model itself, but it seems to either prefer winter or summer data in terms of making its predictions. So you can configure that. And again, UK CP9 datasets come in daily or monthly format, so you can choose to base on daily or monthly. And down here we can see our data slots that we filled in on our model. So again, these point to UK CP9 datasets, but if the UK CP18 dataset gets uploaded to DAFNI, I can press the edit button, find it in the catalog, and just swap those 2 datasets out for each other, if that makes sense. And so once I'm done with that, I would upload that parameter set, and then I can just click run, and that would do an execution. Again, that takes some time, so I did do that earlier and produce some visualizations. So I've got a Jupyter Notebook one, but obviously Zeus has demonstrated that quite nicely. So I'll just show you the drag and drop one instead. So this is a list of all the files that have come out of my model. And so the kind of ones that we're interested in this model are the predictions, because obviously we want to know what's going to happen in the future. We've got all the data about what happened in the past. And so when I select this CSV file, this column section down here gets automatically populated with the column names from the CSV itself. I can then drag those onto the X and Y axis to make a graph. So if I drag the year month onto the x-axis and the values onto the y-axis, I can kind of see what is going to happen. In fact, this only goes up to 2016 for some reason, but I don't know why that is. Change that to the ordinal, because obviously it's a date rather than numerical, and you can kind of see it creeping up a little bit. So hopefully that fits with the actual predictions of, I think this is maximum temperature. Again, I can't comment on the validity of this model, but yeah, hopefully this just shows you that we've provided an easier way for people to do visualization.